Hi, everybody. I wanted to pop in and we're going to have a quick conversation here about the Chapter 3 and 4 test. I got quite a few emails from you guys saying that you were concerned about the results. Now that I've had a chance to grade them, I see why. By and large, they weren't awesome. They weren't, the world will not end. Okay, first, don't panic. But we're going to talk through a couple of the key questions that I think were issues here. But before I do that, there is one important thing that I noticed. And from the perspective of a teacher, one of the things that I think is important that you realize is that in a test like this in math and in many other subjects, what I saw here is that when you weren't sure what to do, you just didn't do anything. And that's not cool. You need to at least attempt the questions. To just leave them blank is not okay. And there was a lot of space in this particular test where there were just things that were blank. Here's the thing, I'm happy to give you partial credit if you're halfway there. But if there's nothing, I can't give you anything. You have to at least take the first step and try. Being wrong is what happens sometimes. But not doing anything is not serving you, and it's not giving me a way to help you either. So we're going to work through some of the questions that were in there and talk about it a little bit. But moving forward, in this class towards the final, and in other classes that you take either with me or in general, what you need to aim to do is attempt things. They will not just because you're not sure doesn't mean you shouldn't try it. All right, so let's screen share. I'm going to share my desktop. All right, I'm going to put up a blank screen on one side and the test on the other. Hopefully Zoom will cooperate with me this time in the recording. So this is number 1, Egyptian numerals, that was okay. Number 2, Roman numerals were okay. What happened in here was more problems with how to write it. So most of you guys got partway there, but remember the MCM this is 1,000, the M. C before M means 100 less than 1,000. So that would be 900. Okay, so that MCM is always going to make 1,900. All right. Where things got kind of ugly here were when we got to numbers and other bases. And I get that this is not anybody's favorite part of this course, but that doesn't mean that you can't try them. They are a part of what's on the final. They are a part of what you're going to have to do in this course. And of course, what I'm writing on isn't working right now. Technology and I are not getting along today. This is a tough day for me to be trying to do this recording with you. Stop Smart Notebook. Okay, we're going to figure out another way to do this. We'll try to do it over here. I wonder if it'll just let me write on it. All right, so what's another way to do that? Yeah, I see you, Smart Notebook. You don't want to cooperate. So we're going to open up the notepad. Sorry for my technical issues today. It's just how my day is going. Okay. Come on. Oh, maybe it'll work. I want a new page. Please. No. Okay. It's not with me. Yeah, I see. Oh, wait, there's my new page. Okay. So when we're talking in base 10, for example, when we're going from a base of a non-typical number, of course, my fingers and my pen are not recognizing each other. This is this is the way things go. So in number 3 here, we're going from base 5 to base 10. Okay, so the way I do that, and it's worth the review, but there is video to review this, and that's what you need to be doing when you practice, looking back at videos, looking back at your prior work. We're going to take 343 in base 5, and we're going to convert it to base 10. When we do that, I think about the little chart in base 5. I start with 5 to the 0, 5 to the 1, 5 squared. One of the problems that I saw in the test was that in some cases you were forgetting the 5 to the 0 column. You were just starting with 5 to the first and it messed everything up. Remember that the first step furthest to the right is that base number to the 0 power. Okay, So I know the values of each of those. 5 to the 0 is 1, 5 to the first is 5, 5 to the second is 25. And I am going to, because I'm going from base 5 to base 10, I'm going to drop in the numbers of my digit here into those columns. So I have a 3, I have a 4, and I have a 3. So what that means is I have 3 times 25. My fingers are cold, so my computer also doesn't want to recognize them on the screen. I have 4 times 5, and I have 3 times 1. 4 times 25 is 75, plus 20, plus 3 gets me 98. Quite a few of you got close to that, but it was either you got close to it or you didn't do anything, which is like disconcerting to me. We're also going to do number 4. Number 4A is to go the other direction. So to convert from a base 10 number to base 3. Okay, so actually, I would rather do number 5, I think. I think it's a better example. So we're going to take 1312, which is in base 10, and convert it to base 5. I need the same chart that I had before, so I'm going to start with that. Remember, 5 to the 0 is first, 5 to the first, 5 to the second, and I'm just going to do a couple over and just see how far I need to go. Because when we convert to a base that is not 10, we use subtraction. So 5 to the first is worth 5, 5 to the second is worth 5, or 5 to the first is worth 5, 5 to the 0 is worth 1. 5 to the second is 25, 5 to the third is 125, 5 to the fourth is 625. I don't think if I go, it's going to be too big, okay? So now I'm going to use that chart, and I'm going to use some subtraction. So I'm going to do 1312 minus 625. I'm actually going to do 1312 minus 625 twice, I think. Well, let's see. I get 687. So that's fine. I can do it again. Minus 625. So when I get down to it, I get 62. Okay. So I used 2 625s. Okay. I could have started with 125s, right, and just subtracted them away, but I would have used too many, because remember in base 5, the only digits I have, 0 through 4. There were quite a few of you that gave me answers with 6s in them. I can't have a base 5 number with a 6 in it, so that's not okay. So I'm going to keep going. I'm going to look at this and go like, okay, well, 125 I'm not going to use at all because 62 is less than 125. Out of 62, I could make 25 twice. I could take 50, and I'm left with 12. So I used 2 25s. Move over here. From 12, I can take 5 twice as 10. Okay, I get 2 left over, and so I can take 2 1s out of that. So my number in base 10 was 1312. My number in base 5 is 20222. Okay? You need to take a look at these. This is important for you to get. This is on the final for sure. I would say the other thing that was tricky in here were the operations with bases. But once we have this idea of how to convert and what to do and what digits we have, some things change. So if I do 9a, remember that in base 6, I have 1, 2, 3, 4, 5, and then I count 10, 11, 12, 13, 14, right? That's in base 6. In base 10, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to do 425 plus 153. 5 plus 3 in base 10 would be 8. But when I look up, that's worth 12 in base 6. So I'm going to put down the 2, carry the 1. 5 plus 2 is 7, plus 1 is 8. 8 is, once again, worth 12. Okay, put down the 2, carry the 1. 1 plus 4 is 5, plus 1 more is 6. 6 is worth 10. There were quite a few cases here where you gave me an answer that was 578. I don't have 7 or 8 in base 6. So that can't be the answer. This is, okay? If we do the multiplication problem, I'm not going to do the subtraction. The multiplication problem was 24 times 3 in base 5. So in base 5, I have 0, 1, 2, 3, 4, 10, 11, 12, 13, and so on. I need to turn my page. So I match up to the numbers. So 4 times 3 is 12. I don't know what that is. This is in base 5. Okay, it's 12 in base 10. So I count 1, 2, 3, 4, 5, 6, 7, 8. I didn't go far enough. So 14, it would be 14, 20, 21, 22, 23. Let's see, 9, 10, 11, 12. So in base 5, in base 10, I need 12. In base 5, that's worth 22. So I'm going to put down the 2. I'm going to carry the 2. 2 times 3 is 6, plus 2 is 8. 8 in base 10 is worth 13 in base 5. Okay? That's what it is. All right, we're going to keep going. We are going to look at repeated subtraction. You guys made a lot harder than you needed to a degree. So remember, in repeated and partial differences, what it means is, yes, you're subtracting away. You draw the line at the side, but I don't have to subtract 9 a million times, okay? I could think about doing it, subtracting 90 at a time, because those are groups of 10, rather than torturing myself, okay? So I get 3, I'd get 333. I could do it again, okay? I'd get 243. I could do it again. I would get 153. I still have 90 left. I could do it again. I would get 63. All right, and I know 63 is 9 times 7. So over there, I would write a 7, and I would get 0. So 10, 20, 30, 47 is the answer here. All right, lattice went okay. Find the sum did not. There was a lot of just didn't bother to try it. It makes me kind of crazy. So remember, we have done this. This is in the first chapter. Tests accumulate to a degree. So when we find the sum, the first thing we do is first plus last. So 146 plus 26. Okay. The second thing we do is find the number of elements. So in this case, I'm counting by 2s. So I'm going to do 146 minus 26 divided by 2, what I'm counting by, plus 1. That whole thing divided by 2. So 146 plus 26 is 172. Times 146 minus 26 is 120. Divided by 2 is 60. Plus 1 is 61. All that divided by 2. Right now it's just multiplication. So the sum here should have been 5,246. You've got to at least try things. Okay? Divisibility didn't go terrible. I will say that I would think that based on the answers I got, most of you need to practice what you do with 3s and 6s. So I would check those rules, please. They're important. Prime factorization. For 775, largely went pretty good. 775 breaks down into, I got a lot of this. You knew it was divisible by 5, but then you didn't know what. You have to use your division skills. Just because you don't have a calculator doesn't make it okay to leave that like that. Not cool. So I could use short division, which is something we learned before, right? I know 5 goes into 7 once. I know there's 2 left over. 5 goes into 27 5 times. There's 2 left over. 5 goes into 25 5 times. Okay. Okay. That's one option. I can divide 155 by 5 again. Okay. So let's say I divide it by 5. 5 goes into 15 3 times, into 5 1 time, 31. So the answer here was 5 squared times 31. Okay. For this, the one with the exponents, 25 to the 4th times. Okay, I think we might still be on the same video. We might be on 2. Zoom hates me. I told you I'm having tech problems today. So we're going to go back to where we were. hopefully. Okay, so I'm going to close, no, cancel. I'm just going to minimize that. So this was the problem, 225 to the fourth, 125 to the fifth times 10 to the third. What you're going to do is break them down into their bases. So 25 is the same as 5 squared to the fourth. 121 is the same as 11 squared to the fifth. 10 is the same thing as 2 times 5 to the third. Okay, 5 squared to the fourth is 5 to the eighth. 11 squared to the fifth is 11 to the 10th. This can get distributed, this exponent, 2 cubed times 5 cubed. And now I'm going to regroup. So I only have 3 2's, but I have 5, 8, 9, 10, 11.